Okay, hello. This is a continuation of the wing. So, when we take the wing and we discuss how its lift is, we've already discussed the phraseology behind it, the terminology. But now we'll actually discuss the dynamics of how airflow actually interacts with the wing. So, what we'll do is we'll take our airfoil again, okay? And we'll just go ahead and color it in so it doesn't. Okay, now as your airfoil moves forward, through the air, if you will, or through the fluid in which it is interacting, it's generating the lift in, what will happen is you'll have relative wind that is flowing parallel and opposite of the flight path. Now remember, it's not just wind, not like the wind's blowing from the east or the wind's blowing to the west. Lift is generally concerned with the relative wind, and the relative wind is the wind or the basically the airflow parallel and opposite of the airfoil's flight path. So basically what that means is that if this airfoil is, let's say, moving this direction, and I'll use a different color. So if your airfoil is moving in this direction, you're going to have airflow moving op parallel, which is parallel with this line, but opposite. So if you take the two vector arrows right there, you'll see that they're parallel, but they're opposing each other's path. Then what you'll have is you'll have this airflow moving over and then under. Now what happens is these molecules of air, if you will, or the flight path itself, is you'll have a point of separation in front of the airfoil, generally maybe like right there, and then you'll have a point where they meet back together. Now if you remember back in Bernoulli's principle that we talked about, and I'll just draw it right here, we discussed how when you take a tube and you have a fluid moving through constriction, the concept behind Bernoulli's principle was that the same amount of fluid at this point has to be the same amount of fluid at the end point right there. The same amount of fluid at the beginning point, which is right here. So let's say you have X amount, has to be the same amount here. So basically your fluid here, your fluid there, has to be the same amount as the fluid moving here. And to do that, as it moves through the constriction, it has to speed up. Well, the same concept applies to your airfoil surface when you start talking about the wing. Essentially what happens is that your airflow will move, you'll have a point of separation, and then it'll rejoin right here. So what happens is that the airflow on top of your lifting surface has to speed up. So your velocity goes up. Now when you have velocity going up, you have a corresponding drop in pressure. So you have velocity up, pressure down. Now what happens here is that your velocity stays the same, or your velocity does not drop as much as it does on here. And what that has to deal is that has to deal with the camber of the line, or basically the curvature of the line. Now the books explain it as that the fluid has to basically speed up to meet the bottom or the trailing edge of the wing. But that's not all there is to it. That's not the full story right there. But for the concept of explaining how lift works, this is a very good starting point. So basically, you have your point of separation. Your fluid moves up, it moves over to your trailing edge. You have your point of separation. Your fluid moves down, it moves over to your trailing edge. Your velocity is going to increase on the top of the airfoil. You're going to have a corresponding drop of pressure. At the bottom of the wing, you'll also have your velocity and your pressure. You might actually have a corresponding increase in velocity with a corresponding drop of pressure, but it's not going to be as great or in the same level as what you'll have at the top. And then what you wind up happening is you have an area of low pressure up here. So these little minus signs stand for low pressure, and an area of positive pressure down here. Thus, you have an airfoil with a low pressure on top, a high pressure on bottom, high seeks low, so then you'll have a corresponding upward motion. And this is your lift vector right there, which generates your lift. Now, you have another concept behind that, or you have another aspect behind that. You have a turning tendency for the air at the bottom or the trailing edge of the airfoil. And essentially how that works is that as your airflow hits the trailing edge, it's redirected downwards at a 45-degree angle. This redirection of your airflow puts a lifting effect on your airfoil surface, which puts in a corresponding direction, moving up. And that is essentially how a wing flies. Hopefully now you're thoroughly confused, so then I can go into even more detail, more videos, and confuse you even more. But yeah, this is essentially the concept behind it, if you want to explain. So there's two elements at work here. There's Bernoulli's principle, which is basically this air aspect right here, which basically discusses the pipe with the speed up effect, where you have the pressure here meeting up with the pressure down there as it goes through here, and then you have your wingtip up here, which is the effect of the airflow moving over the wing, and then which is the effect of the airflow moving over the wing, and then you have your velocity vectors or velocity arrows. So if you have any questions, let me know. I'll also put this in writing and put it on the website, but if you have any more questions that you want me to go specifically into detail, just let me know, and I'll go ahead and conclude this video right here.